Hello everyone. Today we are going to learn about probability. So previously you learned about descriptive statistics. Now we are going to use what we learned before, but we will try to look at what are the chances of events. That's our goal today. So let's see what we have in the probabilities. I will try to give you some examples and give you some highlights so that you can easily read this lesson. So let's give you some examples about probabilities, and you will get to see in the book chapter we have lots of examples over there. So in an area, can I say next year whether this area will be affected by fire or flood? Let's say in a forested area. So how many trees this year will be infected by insects or other kinds of diseases? Based on our historical data, based on, let's say, some samples, what we collected before, we can say what are the chances. That means we don't know, it might be happening soon, or we don't know, it might be 100% what we are saying, but we are saying that there is a possibility that it might happen. So those are kinds of probability that we try to find in those cases. Or let's say we have a sample set or historical data, and we made inference about what might be happening, how we are doing that. So we need some data set. Data set is something that you need to know, or maybe from other studies you have some ideas. Then you can say what are the possibilities. Or let's say in a gambling situation, let's say I have a deck of cards, and in a deck of cards we have 52 cards, and I'm going to draw, let's say, 4 cards. Among those 4 cards, 4 will be aces. What are the chances? Then we can think of how many cards were there, how many aces can be there, and then how many times I'm actually picking them, drawing them. Depends on all these, we need to calculate a probability. If I say what's the chances of getting 1 ace versus what's the chances of getting 4 aces, the probability will be lower in the second case, right? Then let's think about rolling a dice. If I roll a die, then what's the probability of getting 6 on the first time I just throw it? Or let's say I throw it 2 times. What's the probability of getting 2 in one of those event? Okay, then we have to think about, in probability, what's the sample space we have. Let's say we are doing some random experiment, and we should have a defined set of outcome. The outcome could be whenever we are rolling a dice, then there could be 6 outcomes. Other than those 6 outcomes, nothing is possible. So that means that's the sample space we have. So you can see over here, that's the sample space. We can have 1, we can have 2, 3, 4, 5, up to 6. So then again, whenever you are talking about the sample space, then you need to think about what are the outcome. Let's say in a tree survival case, we're thinking about a tree could be live or tree could be dead. What's the possibility that a particular tree will be dead next year, or it will survive? That means there are 2 possibilities in there. Okay. So in this example, since we are talking about rolling dice, that's why we have 6 outcomes, and then each of these outcome possible outcome are called element. If I'm talking about a deck of cards, drawing cards from there, then how many would be there? So there would be 52 possible outcomes. Each of those will be an element. Let's talk about events. What is an event? So in an event, what we do before we talk about event, we try to get what might be the sample space. So sample space you will always write down as capital S, and then events will be some of these samples, some of these elements will be in an event. So let's say, for an example, you can see in this example, we are saying that we have a subset of sample space. In that sample space, there are some objectives. So we are saying that whenever we are rolling a dice, then event A, so we gave event A a name. That means A is the name of the event. And then in that event, what will be included? So let's say all the even numbers will be there, and all the odd numbers, or maybe some of the odd numbers, will be in another event. So we always name this as capital letters. So you can say A, B, C, or D, but S would be used only for sample space. So we could have different types of events. We have some names of them depending on what we are getting as an element in each of those events. A simple event would be just one element in there. A compound would be more than one. A null would be none of those events, none of the elements are there from the sample space. And then we have, we actually give them a symbol. You can say that. There are a few more cases and a few more possibilities we could have. So let's say from a sample space, we have two events. So you can see previously we have two events A and B. In those two events, you can see we have some of them. That means one element is common in those two. And then 3 only came in B, 2 and 4 came only in A. So whenever we are talking about intersection, let's say two events A and B, and then intersection will be denoted by the this symbol. That means we are talking about intersection between them. So intersection between them, so you can see that if I try to find the intersection, that means only common element is 6. So that's why the intersection A intersection B, we call that way, and then it's only 6. So whenever you try to remember that whenever you talk about the elements and then add the elements in an event, you should add them using curly brackets. Okay, so before the equal sign we have the events, and then after the equal sign, what are the elements in that event, we add them using curly bracket. And let's say we are talking about union. So union means joining them. So you can see 2, 4, 3, 6, they came into A and B, and we add them all. But we are not going to repeat 6 twice. So you can say I wrote 6 only once. And then complement. How about the complement? Let's say we have event A, 2, 4, 6. The complement of event A would be the other elements we have in sample space. 2, 4, 6, that means we don't have 1, 3, 5. So 1, 3, 5 is our complement of element A. So you can see complement is denoted, that means we gave them a symbol where we have the event name and a prime sign. So you will see that there is another kind of event we can have is the mutually exclusive event. So two events cannot occur together. Let's say, for example, the occurrence of one event can affect the other event. That time we say that those two events are mutually exclusive. So you will see that I gave you links of some other sites and gave you some examples later on this module. Then you can take a look at those examples. Okay. So another way we can actually visualize all the events, sample space, and elements. This is what we call Venn diagram. So in a Venn diagram, we will have a space, everything inside a rectangular. So let's say, so you will see that we all have some examples in the book chapter. So we can draw, let's say like that, we can draw a rectangular, and then that rectangular, we call it the sample space. So within this sample space, we can have all the events inside the sample space. So you can see that we have event A and then event B, but event A and B, they have overlapping areas. That means this is actually the intersection. And then we have another event that is actually C, but all the elements in C also exist in element A. That might be way easier to understand. And then whenever we are talking about complements, so let's say we have event B. So event B we have, and then complement of event B will be everything. That means other elements that we don't have in event B. That means excluding the elements in the sample space that we have in B. So we actually draw it. We say that this is B prime. In this example, you can see that we have overlapping areas. That means this is the intersection. We also can talk about, let's say, the union of two events. So that means union of two events will be these ones. That means A and B. But you cannot count the intersection areas twice. So intersection areas, and then you can see we have two events. There is no overlapping areas, but even A and even B both exist within sample space S, and they can affect each other based on what are, let's say, the elements we have in A cannot be in element B, and that they are disjoint. They are actually mutually exclusive events. Okay, so let's go back. So that's what we actually talked about. So we can have different types of events based on what type of event, based on what's included in the sample space, what we have in those events. Then we can come up with an idea. Let's say if I say what would be the complement of event A, what would be the intersection between two events, what would be the union of those two events. Then you can draw a Venn diagram, easily find them. So you will see that in the assignment I gave you some examples. So in those examples you are given a scenario. In those scenarios, then you have to think about, in the sample space, what we have, all possible outcomes, and then events. Then think about the events, write them out. In each of those events, what we have as an element, and then in the question, am I asking about joining them? Am I asking about intersecting them? What is it? Then you can write them. Okay, so next item will be on how we can calculate probability. So in the next video you can see that. Thank you.